Hey guys, welcome to our last series on videos on light. So right now we're gonna talk about just gonna show you a simple simulation on lenses. Okay, as you can see here, in the right in the middle is a lens. If you want to change the curvature, that means I make it thicker or thinner. What do you notice? You actually notice that. Okay, let me just move this further away first. Object. Okay, by changing the curvature, you notice there's a change in this x, right? So why is this x? Oh, I changed the refractive index. That means I changed the type of material. You see the change in this x. This x value is basically your focal length. So it is a fixed value for certain type of lens. So for example, your glasses, all our glasses have got a certain focal length. Okay, so this focal length, this point is known as the focal point, and the distance between the center of the lens, also known as the optical center, to the focal point is known as the focal length. Okay, so what's the purpose of all this? Okay, so that's actually a purpose of all this. Okay, let me just show you a little bit of this. Okay, if this is the object, you see I can't really move this. Okay, because this is the image, the one on the right is the image, the one on the left is the object. If I were to show all the light rays that actually comes along with it, you can see some rays actually go out, some rays gets refracted inside the lens. Okay, so if I were to move the object further away or towards the lens, you can see my image also on the right. It actually changes bigger, smaller, and it also moves further away or nearer to the lens. Okay. Alright, but how do I actually know exactly where to locate the image? Okay, that's where principal rays comes in. Okay, what do I mean by principal rays? Principal rays to locate the image is very simple. The first ray you need to know is this ray right here in the center that actually passes through right in the center of the lens, also known as the optical center. Can you see that? It actually cuts through right in the center of the lens. So this ray here doesn't get refracted, okay? The second ray that we draw is the one that is parallel to this horizontal line here. This horizontal line is also known as my principal axis. So any light ray that is parallel to my principal axis before the lens, after the lens, it will actually cut through my focal point. Okay? And the converse is also true. Any light ray that passes through my focal point after the lens, it will be parallel. And you will notice all of three of them actually will intersect at the same point. And since this is the top of the lens, and this is the top of the object, the pencil tip, the image, this will be the tip, pencil tip also. So that's why the image is actually inverted over here. In other words, actually you don't really need three rays, you just need two rays. The third is more or less serves as a confirmation. That's about it. Okay? Alright, so now we just go to refraction, the last and final part for light. Refraction by thin converging lenses. Okay, here are some of the terms we mentioned earlier. Principal axis is the perpendicular to the vertical plane of the lens. This is my lens, it's a perpendicular line. Okay, this one is principal axis. Optical center here is the midpoint between the lens, the midpoint between the surface of the lens and the principal axis. Okay, so it's basically an exact center point. Okay, focal point F, also known as my principal focus, is the point where all rays previously parallel to the principal axis will converge after being refracted by the lens. Okay, so this is just known as my focal point. And my focal length, which is important, is basically the distance between optical center to focal point. Focal plane is basically something like made up of a plane, a surface that the plane surface that cuts through the focal point that's perpendicular to my lens and principal axis. Okay, so what's the significance of focal plane? You can see if my light rays are still parallel but to each other but not to the principal axis, it will still focus on my focal plane, although not at the focal point. That's about it, what they are saying. Okay, so just a quick summary. Converging lens converges a beam of light. Focal length of a lens is the distance between optical center and focal point F. Okay, so how do we draw? Just now in the simulation I already showed you. Okay, we actually have three rays. To actually draw, we actually need only two rays. The third ray serves as a confirmation. So first ray, that passes through the optical center does not get bent without bending over here. Second ray, anything that's parallel to the principal axis, after that it will bend. And the third ray, anything that passes through the principal focus, after that it will be parallel to my principal axis. Okay, so what happens? How do I actually draw? Okay, let me just show you yet another simulation here. Okay, if I have an object that is placed, object distance longer than the focal length, that means less than 2f, greater than f. Okay, so my object somewhere here, how do I draw that? Okay, I just show you a simulation. This is what I actually came up with to zoom in. Okay, my object is between f and 2f. First light ray, easiest. Anything that passes through the optical center, no bending. Second one, can you see? Parallel. After that, where do you think it should go? It should go through my principal focus. Good. Third one, anything that passes through principal focus, after that will be parallel. And boom! Can you see? All three actually intersect. So what does this mean? This means that the tip of the arrow, I should actually draw an arrow down here. Okay? So, these are locations of. Okay, this table over here is important. Okay, let me just make this continuous. Just give me a second here. Okay. These are just an object at different distances. For example, an object at infinity, that means a very far away object. For example, a tree across the street. If it passes through a lens, it will actually, the image will be formed and my principal focus. Okay, anything that's bigger than 2f, you notice. Okay, over here. Okay, where's my, okay, bigger than 2f, this is f, 2f is somewhere here, so bigger than 2f, you notice my image is still inverted and it will be smaller, right? So that's why inverted, diminish or smaller, and real. Real mainly simply means it's on the opposite side of the lens and it can be captured by a mirror. How about u equals 2f? Something special happens to a 2f, so let's say this is f. I move 2f should be somewhere here, so let's just move it somewhere there. Alright, do you notice anything about the image? It's exactly the same size, right? So that's why at 2f, it's still inverted, still real, but same size. So an example would be a photocopy machine. The previous one was camera. Okay, so that's at 2f. What about between f and 2f? This one we did earlier. So between f and 2f, I come nearer here again. You see, it goes bigger. So that's why it's magnified, real, inverted. Projector. Okay, projector, we don't really use it now because this is the old school OHP. Because today all our projectors are electronic. Okay, what about at f? Okay, if an object is at f, you notice, whoa. What do you notice about these two lines? They will never intersect because they are both parallel. So what will happen? You see, I never see an image. That's why the image, instead of being real, what happens is that I just click on the virtual image. If you cannot connect points by drawing the rays, always go backwards. By going backwards, this line in green should actually be dotted, and you see the image is on the same side as the object. Okay, so over here, if it is less than f focal length, it's upright, virtual, magnified. Image behind the object, and use will be magnifying glass. Okay, so we'll just go through some of the workbook examples below. I've got some of the solutions, and we have actually went through most of the examples in class. Okay, I hope this series of videos you found it useful. So just a quick recap on lenses. Okay, incident ray when drawing ray diagrams. Incident ray passing through the center does not refract. This is the first ray. So anything that is after that parallel to the principal focus is refracted through the focal point of the lens on the other side, and another ray that passed through the focal point on one side is refracted parallel on the other side. Okay, so these are just some of the things to take note of. An object placed further than focal length has a real and inverted image. Okay, so actually there are more than these two cases. There are actually a couple more cases, which is all found in this table over here. Okay, as mentioned in class, you don't really need to memorize this, but what you can do, you can actually do a quick sketch over there. There and then when there's a question arise, just make sure your sketch is pretty much accurate. Not say, not something like F and 2F is like 3F or something like that. So you just roughly measure it, use your ruler, you will be able to get all these properties of images. Alright, hope you benefited. Hope you found this video useful. Happy studying, and okay, I'll see you soon. Bye.